Now let me define the definition of normal subgroups. It is defined in this way: a subgroup H under the binary operation dot of a group G under the binary operation, same binary operation dot, is a normal subgroup of G if and only for every X in G and for every H in H. If X dot H dot X inverse belongs to H, then in that case H is said to be a normal subgroup of G. Or it can be defined in this way also: if X dot capital H dot X inverse is contained in H or is a subset of H for every X belongs to G, then H is said to be a normal subgroup of G. If H is a normal subgroup of G, then it is denoted by this notation H. This is a notation for a normal subgroup of G. So let us use this definition to find. Let us discuss this definition through an example, simple example. Again, I am considering the simplest example of a group by taking G to be the set of integers or the group of integers under the usual addition or ordinary addition, where set contain these elements 0, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and so on. Now we know that this one is a group under the ordinary addition. Now take H to be twice set. Twice set is a subset of set because twice set contained only the even multiples of the even integers or the multiple of 2. It will contain these elements 0, plus or minus 2, plus or minus 4, and so on. Now clearly this one is a subset of set of integers. So now let us show that this one is a normal subgroup of G. So to show that H is a normal subgroup of G, I need to show that for every X belongs to G and for every H in H, X inverse should belongs to H. So here you have to note down the operation between small x, H, and this one small h and X inverse. It will not be that dot because dot can be at the usual addition or the usual multiplication or any other operation. But in this case, since the binary operation defined in the set of integers is the usual addition or the ordinary addition, so the binary operation between the elements of X between any elements of H and G also will be plus. So for example, take X to be, let me take X to be an element of G, say 1. And then take 2 to be an element of H. Now what is X plus 2 plus what is the inverse of X? Or the inverse of 1, it is minus 1. So let us see whether this one X inverse, which is equal to this, in this case the binary operation between X and H, it is plus, so you just have to replace that one. So here it will be 1, please correct, this is 1 plus 2 plus of minus 1 gives you what? It will be 1 plus 2, it will be 3 minus 1, it will become 2, and you can see it is still an element of H. Or if you take X is equal to say minus 5 and then H to be say 4, which is an element of H. And let us see now what is X inverse. X inverse in this case, X is equal to 5 and minus 5 plus H. What is H here? It is 4. Then what is the inverse of minus 5? The inverse of minus 5 is 5. So this will be plus here. So it will be minus 5 plus 4. It will become minus 1. Minus 1 plus 5. It will be equal to plus 5, which is equal to 4. Still an element of H. So it satisfies that for every H belongs to H, which is equal to 2 set. That means a multiple of 2. And then X belongs to G. Then X inverse still belongs to H. So here this implies that G is equal to set and H is equal to 2 set. Then 2 set will always be a normal subgroup of G because it satisfies the condition that for every H in H and X in G, X inverse belongs to H.